Oh, okay. Good morning, everyone. Today we're going to talk about MLP, multi-layer perceptron. Okay, so we are going to realize multi-layer perceptron with Keras. So this with for the lab, for the students in this lab, we've already talked about it in yesterday's lecture about Keras, right? And today we are going to deal with a previous data set, this Pima Indians diabetes data set. Okay, we would like to classify, or we say predict, if the people with some features have diabetes or not. Okay, so at the beginning, please open the notebook. You can download from the OLE and also the data set. Okay. So in week 11, lab 10, and the data set. Okay, and then we need to first import the library. Let me see if we have Keras. Yeah, okay, so we have built-in Keras. We don't need to download. Okay. We can directly use this cell. And for your own computer, if you're not doing in the lab, you might need to download the Keras library. Okay. And okay, firstly, we need to load the data set. Okay. As the workspace here, you need to load the data set to a workspace, to your files. And then we read the data from the data set. So what the data set looks like. So actually we talked about it before in the week 9, I think. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 features. Okay, and then we are going to use these 8 features to predict the last column, which means the indicator of the diabetes. Okay, each column represents for a feature. In total, we have 8 features. And we have how many samples? This time we have 768 samples. Okay, so we first read the data set. So as shown in the data set, we read all the rows and the first 8 columns. All right. This should be data set, sorry. Data set, not data. Okay, also the Y value, the target value is the last column, 8, the 8th column. Yeah, here the X still bring. Oh, this we oh yeah, this is this time we use NumPy. Okay. Yeah, we didn't use data frame. Okay. This time we use a new function to read the data set, which is load.txt in the NumPy lab. And then so previously we're using data frame. So if we use NumPy, I think we don't have this header. Header function. No. Yeah, sorry, I mixed some language. Yeah, you can see that this time our data is a NumPy ND array. Okay. So if you still remember in the first lab, for this neural network, we can only use NumPy array as an input. Okay. We cannot use data frame as an input for the neural network. Okay. So because even we load the data with data frame, we need to convert it to NumPy array. Okay, so that's why we directly load it as a NumPy array. Okay. Okay. Then we can check the shape. X dot shape. Yeah, we can check the shape of X and Y. Okay. This is like just a habit that before you are using this neural network, you need to make sure that your input, the shape of the input are correct. So this time we have the input of the X is like 8 features and 700 more samples. Okay. And then the Y for the Y value, for the Y array, we only have a column, single column with 768 samples inside. Okay, then we can start to build the model. And this time we need to import two libraries. One is the sequential, one is the dense. The sequential means the structure of the model. Okay, so it's a library. It's a function in the Keras library to build a sequential model. Sequential model means that you connect different layers together. Okay, and then also this time we only use dense layer, which also means fully connected layer. Okay. This also means fully connected layer. Okay, then as we've talked in the previous lecture yesterday, so we just need to define the layer we want with this model.add to add layers to the model, to the sequential model. And let's say we want to add the dense layer. Okay, so the first dense layer is also the input. Okay, so we have 8 input features, right? So we need to define the number of neurons as 8. And then we also put the, oh, sorry, this is the output. This is the output, is 8 output, okay? And then we define the input dimension. Input dimension, also 8, because we have 8 features. And then we can also define our activation function here. So this is the activation function for the output of this layer. Okay, let's say we use ReLU. Okay, so this is a simple layer that we can define. Okay, so we have 8 input and 8 neurons for output. And then we connect with a ReLU function. Okay. And then we can put another layer similar with this one. For the second layer, we don't need to define the input dimension because it will automatically use the output from the first layer. Okay. So because the output of the first layer is 8, so we don't need to define the input dimension again. Okay. So for example, we define the output dimension of the second layer as 6. These are all the parameters you can change. Okay. This is just an example that we use 6 here. Okay, and then let's say we are going to build a 3 hidden layer MLP, and then we need to put the last layer. Okay. So the last layer, the output is 1 because we are going to make a binary classification. The output is either 0 or 1. Okay, so we only have one output, and the value of this one output will be 0 or 1. Okay, and then we need a sigmoid function, similar with logistic regression. Okay, we use sigmoid function for binary classification. Okay, if you forgot like why we need to use sigmoid function, okay, have a look here what it looks like. Because sigmoid function will map the output to a value between 0 and 1. Okay. So because when it has higher possibility or has higher value, it means it's closer to 1. Okay, so when it is closer to 1, it means diabits. Okay, and then if this is smaller than 0, then it means no diabits. Okay. Okay, so this is a simple model. And we can then we compile the model. Okay. So we need to define the loss function, the optimizer, and the matrix that we use for the model. Okay. Let's see, we build the loss. We define the loss as binary cross entropy. Binary cross entropy. Entropy. Cross entropy. Okay. And then also we need to define the optimizer. So this is for gradient descent. Optimizer. Okay, we used atom optimizer. Okay, it's a variant of gradient descent. And there's also another one you can use like SGD, stochastic gradient descent, something like that. Okay, and this time we use atom. Metrics. So this is the performance metrics to evaluate the model performance. We use accuracy. Okay. So now we've already defined all the hyperparameter for the model. We just need to fit the model. Similar with sklearn, right? We use the function of fit. Sorry, we fit x and y. Okay. And for neural network, we also need to define the epochs. How many times you feed the data to the to the model? Sorry, yeah. And this also need to define something called batch size. I've talked in the previous class. Batch size. Variables that it doesn't matter. Okay, so batch size is like we divide the data set into mini batches. Okay, let me draw something here. So in total, we have 786 or 668, 68 data, right? And then every time in each epoch, okay, we take 100 samples every time. So this is called mini batch. This is a big batch size, okay? We take 100 samples out every time to train the model. Okay. And then in each epoch, how many times we need to take? Of course, we need to take 7 times or 8 times. Okay. So every time we take 100 samples to train the model. And then the last one is we have 68 samples remained. Okay, so this is for the last part of the data set. And then the whole process here is called epoch. Okay. So this is a batch. BATCH batch. Okay. It's a batch. Each batch is each mini batch. Always a mini batch. Mini batch. Mini batch. And each mini batch we have 100 samples inside. And then we put these subsamples, a subset, this mini batch to the model, to train the model. Okay. To train the model. And after we consume all the data in the data set, it is called one epoch. And in this model, we are going to run 30 epochs. Okay, and then in each epochs, we get data with a mini batch of 100 every time. And we will take the data for 8 times in each epoch. Okay, so this is how we feed the data to the model. But these are also hyperparameters. You can adjust it by yourself. Okay. If no questions here, I will just delete the drawing. Okay. Okay, and then the last step, just to evaluate the model. Okay, we train the model and then we put the data back to the model. Okay, we put the data back to the model and then we just print the score. and then we run it. Very fast. So you can see my accuracy is 61 something. Okay, so your accuracy might be different with mine, but doesn't matter. Nothing wrong here. I think it's okay. It's not an error, but only its input dimension. So if you didn't put the input dimension, it's also fine. Okay, it will automatically check the input data. It will automatically check the dimension of the input data. And if we don't put the input dimension, it's also fine. Okay, but you can see here, every time you run the model, you will have different accuracies. Okay, oh, this time very low. Yeah, this is because the performance of the model in these 30 epochs is not stable yet. Okay. Later we can do with other parameters. Okay. Okay. So then let's go for the next section. So in the next section here, we are going to build another model similar with the first one, but we are going to use different parameters, hyperparameters. Okay. So for example, we just increase the number of neurons for the first layer to 12, and the second layer to 8, and the last layer is still 1. Just copy paste from the first thing. Okay. And no other things are the same. Auto fit. Several times. Okay. So you can also change the epochs, the batch size to test your model. Okay. I think so the thing model dot history. Model dot history. Okay. So I think we don't have quite a lot of content in this lab. And here is an exercise for you. You can restart things and try different hyperparameters to test your model. Okay. And So you have some extra things here. Okay, so if you want to check the history of the model, you need to first, I've got to define the history here. You need to first define a history. Okay, when you do the model fit, you need to instantiate something. Okay, to put the record of the training in the history. I mean, you can use any kind of variable here. Okay, and then you just use history function. Okay, and then you can get the accuracy of each epochs. So here we have 30 epochs. So then it will plot it can show you all the accuracy in the history for each epoch. And then you can use the matplotlib function, ml dot, okay, to plot a figure about the, let's say, the training accuracy of each epochs. Okay, and then in this case, we can see that like 15 or 10 something, some value between 10 to 15 might be already enough to train the model. Sometimes we got very low accuracy. Check if we only got the, yeah. So actually the training process is not very stable in this setting, okay? So you can see like we just change the parameters. And then for now we have the best accuracy of like 70% something. This is just like a rough example. Okay. So in your case, you need to check both the training accuracy and the validation accuracy. Okay, because here we didn't split the data into train and test set. We directly use the whole data set to test the model. Okay, and actually the model is not good enough. What happens if we do that? You will see here that when you decrease the batch size, it will take longer time to train. Okay, because every time if you use a very small batch size, then every time it use only 10 samples. Okay, so in each epoch, it need to take 70 times, 76 times from the data set to train the model. Okay. However, when we were using like 100 before, we only need to take 7 times or 8 times for each epoch. So it will be much faster. So this is also kind of trade-off in your training to decide the batch size. Okay. So when we increase the epochs to 200 and use a very small mini batch, okay, now we already got like 77 accuracy. So but because usually if you run more epochs, it might overfit. Okay. So you need to also need to check the validation accuracy. And here we can also use some GPUs, for example. Okay, so by default, we can like just click file here. Oh, no, sorry, edit here. And then there's a option called notebook settings. And it provides you some GPU that you can use. For example, we use the T4 GPU. Okay, let's try. But after you change the computing resource, you need to reload everything. Okay, you can see even here the data set disappeared. Okay, now here it shows you that you're using T4 GPU. Okay, and then we just run all the things again. Directly use this mode. Okay. Ah, okay, doesn't matter, doesn't change because you need to use CUDA. Okay, when you use GPU, you need to use the CUDA. Or it will still use CPU. You need to deploy the model in GPU with CUDA later, but we don't have time today. Okay, so it's the end of this class. I mean, all the things I'm talking about in the later part of this lab is just extra things. Okay, it's not the content. I just want to talk about it. It's not the content of the lab. Okay, so I guess you've already finished your exercises. And thank you very much. See you next week.